Yes,
Go ahead,
Sandesh.
Sandesh. The stage is yours.
All right. Thanks a lot, Brian. Thank you, Vandana. And thanks for the lovely introduction, Vandana. I think you put things really, really well. So let's get started. I know I have 30 minutes. At any point, if you have questions, please feel free to type it out. I'm sure I know Brian will stream them to me at the end of the talk, Brian and Vandana. And I tend to speak a little fast. So if you want me to slow down, just let me know, and then in the chat, and I am happy to repeat a section or two. So let's dive in. Just a little bit about me. I work at Razorpay's security team. Razorpay is India's largest payment gateway. It's also building a fintech stack for all digital businesses in India. We've been scaling incredibly over the last few years, and scaling engineering is a key part of that as well. And to give you a little bit of background about the Razorpay stack, right? Because it'll probably put some of the points I make in context. We are cloud first, so all our production workloads are on AWS. Mostly on AWS. We are microservices first, which means everything we build is part of a microservice. We are API first, which means that our merchants across India integrate with us primarily through APIs. So everything we build is usually an API, right? So from that perspective, we kind of have kind of the cutting edge of a CI/CD pipeline, working in our ecosystem, and that's what we've been trying to secure for the last many years. And I was one of the earliest engineers to join the security team, and we've kind of scaled it to a full-blown security team right now. Apart from being at Razorpay, I also I'm author of Boring AppSec. Boring AppSec is a newsletter where I write about whatever catches my fancy. It's usually an essay on certain topics on application security. Yeah, it's called Boring AppSec because a lot of us focus on bugs and fixing bugs and research, vulnerability research and stuff. And I want to talk about the other aspects of application security. So tongue in cheek called Boring AppSec. You can also follow me on LinkedIn and Twitter. Okay, so let's get started. So what are we going to talk about, right? So we're going to quickly talk about why DevSecOps is hard to scale. I'll kind of quickly run through that. I'll provide a few caveats about this talk, right? Because it's really hard to cover a topic like this in 30 minutes, right? So I want to make sure that there are certain caveats that I mentioned. I'll walk you through 4 frameworks, which has really helped us scale DevSecOps. And also I'll tell you exactly how it benefited Razorpay, right? And finally, we'll wrap it up with key takeaways. And if we have some time, we'll do some questions as well. So let's dive in. So why is DevSecOps so hard to scale, right? I think there are many reasons why, and I'll walk through 4 of them here, right? So first of all, when I started, working at Razorpay and I was looking for guidance on how to scale DevSecOps, what I found was most of the advice that you either find on the internet or by experts are well-meaning, right? And they probably work, but they come into the category of too generic or too specific, right? When I say too generic, something like shift left makes a lot of sense to me, right? And a lot of our success is because of shift left. But when somebody asks you to shift left, it's really hard to know what they mean and how it will work for your organization, right? So some of it is correct, but generic. And others are case studies, right? Now, case studies like how we scaled X is very inspiring, and it inspires you to do better. But it only works for that org. An example I want to give you is an excellent blog series by Netflix, right? So Netflix has engineering blog, which if you haven't checked it out, I would highly recommend you do it. And they have some blogs on how to scale their AppSec program, which was phenomenal. I was so inspired when I read them, right? But the reality is that works for Netflix, right? Netflix is a very different company from Razorpay, right? So how do we kind of apply that to Razorpay, right? And that becomes very hard. So when you consume advice on the internet, like you are with me today, be mindful of the fact that the advice can be generic or too specific, and you'll have to really temper that to your situation. And I mean that's one of the reasons why it's hard to get like a playbook on how to scale, DevSecOps just off the internet. Second is that DevSecOps creates a lot of drama in your engineering organization. So what do I mean by this, right? At first, application security, DevSecOps is very exciting. You're finding bugs, you have a bug bounty program, people are reporting issues, you're fixing them, you're feeling really good. But a few months in, it gets tiring, right? Your application teams are frustrated with the number of bugs you find. They're frustrated that their sprints are getting getting stalled because of the bugs you find, and they're getting tired of this, right? And they want to just go ahead and build, right? And at that point is when you need to kind of figure out how do we reduce the drama, etc. And this is not something you realize when you start building a DevSecOps program, but as you scale, this becomes really, really hard. And this is one reason why it's hard to scale programs. Third is that in other areas of security, like let's say incident management, right? Most of the work is actually done by the security team, right? So they may have to coordinate with incident management or a few application teams or a few in the infrastructure teams, but the heavy lifting on security operations, threat intel, etc., is done by the security team. But that's not true about DevSecOps, specifically application security, right? A lot of the work actually has to be done by the application team. Security teams are just enablers, right? So you have to have the ability as a security professional to sell security to your engineers, right? And if you don't have that ability, in the long term, it becomes very hard to scale. Finally, it's very easy to create security debt in DevSecOps. What I mean by that is that you start off with programs which work very well initially, but as you scale, it becomes really hard to scale, or it leaves behind a lot of areas which are hard to scale. So, for example, manual penetration testing. You get some great bugs initially, but over time, there's no way you can scale it to hundreds of applications, right? And then if that's the only game in town, then you can't really scale your program. So these are the very high level, why DevSecOps in general is hard to scale, right? And I can promise you, even at the end of these presentations, a lot of this will apply, which means that, you need to really build a program and do that for many, many quarters and years to kind of actually, get through all these challenges. Okay, so before I get into how you can actually scale your program, a few caveats, right? So treat the frameworks that I provide as a compass, not a GPS. What I mean by that is that the goal of the talk is to make you think. It's to give you a North Star to think about, and not give you turn-by-turn directions, right? So I'm not going to say step A, B, and C, and you scale your program. That's not going to happen, right? So the idea is to give you some ideas and thoughts, and then see how we can apply that to your org. Which goes into the second one, right? That each org is different, right? So while the basics of application security and DevSecOps and cloud security is kind of the same across the board, each org will have a different scaling journey, right? And it's important to respect that. Third thing is, you can take some of these frameworks and apply to other aspects of security too, especially given the first principles for security are kind of the same, whether it's product security or security operations or even compliance in some way, right? And finally, this is not exhaustive list of things to do when you scale your program. This is something that could fit in 30 minutes, right? So these are probably the four most important frameworks to scale, but there's obviously a lot more to be done. Okay, so with that out of the way, let's dive in. So first framework. One of the first things you do when you start a security program is you figure out how do you perform assessments, right? How do you find security vulnerabilities? In the previous talk, we heard about a company which spent so much time finding things with on systems which use GraphQL, right? But if you're a security professional who has a background in pen testing, that's usually where you start, right? And there's nothing really wrong with that. But while you scale, it becomes important to figure out which assessment type you want to choose, right? Now, the obvious question that comes to my head is, why not do everything? Why not do SAST, DAST, IAST, everything, right? The answer is pretty simple. It's a resource constraint, right? You can't possibly do everything all at once, right? You will not have the bandwidth or the budget to kind of pull it off, which means you'll have to pick things which give you maximum bang for the buck, right? And that's why choosing assessments are important. I break assessments down into three different types in my head, right? One, I would say, assessments which analyze design. So think about threat modeling, design reviews, etc. Second is assessment time which review code. So think about static analysis, software composition analysis on manual code reviews. And finally, with simulate an attack. These are pen testing, DAST tools, red teaming, and so on and so forth, right? So you know all about assessment types. You know that you can't do all of them. All of them are useful in some ways. So how do you start, right? Which ones do you pick? So here's a framework that I want to talk to you about. So I think you need to think about three different aspects. One is support for scale. Second is support for customization. And third, how much drama does it create, right? So let's tackle the first one, support for scale. So what this essentially says is, how easy is it to get things up and running? Get this assessment type up and running, right? So for instance, if you're doing manual pen testing, it's actually pretty easy to get it up and running once, but you can't really get it up and running for hundreds of applications at the same time, right? But for static analysis, this may be easy if, let's say, all your code is in a single place. Let's say all of them are in GitHub, all of your CI is through GitHub Actions, then it's actually SAST is pretty easy to automate, right? And the second thing is, how easy is this to teach? Like I said before, a lot of AppSec is done by developers and engineering teams. And if your assessment types are very, very hard to understand, like say threat modeling, then it becomes very hard to scale, right? So think about support for scale as the first, kind of axis on how to choose assessment type. Second is support for customization, right? It's really important that the assessment type and the tool you're choosing actually works for your environment, right? So you need to make sure that there are sufficient integrations in place so it can actually fit into the developer's workflow and not just the customer workflow, right? So if you have a third-party vendor doing pen test who's giving you PDF reports in dense language that nobody can understand, that does not integrate with your lifecycle, right? On the other hand, if you have a tool which kind of creates Jira tickets, creates PR comments, then that's good customization. The next is the ability to write custom rules, right? Now, look, I think, I've spent about 15 years in security, and I kind of know one thing, right? No tool can give you all the rules you need out of the box, right? Whether it's SAST, DAST, IST, whatever it is, right? So what you really need is that you need to have a good basic rule set, but you need to have the ability to write rules that work for your organization, right? And this is a key decision, the key aspect to think about when you're looking at customization, right? And the third one, which I think is kind of a little controversial, is about how much drama does it create, right? Now, let me be honest, right? Too much drama is not necessarily a bad thing. If you're in a company where your engineers are still not convinced about security, if you're just starting on a security journey in your company, then maybe some drama is good, right? If they don't understand why security is important, then doing a manual pen test and showing an exploit is actually a great way to convince them on why this is important, right? But it creates high drama. It creates fear in the minds of developers where, what you should actually be doing is giving them guidance on how to avoid this in the future, give them remediation guidance and do it at scale, right? But that only works if they're already on board with security, right? If they're not, and if they need convincing, then maybe a little bit of drama is not such a bad thing, right? But you have to ask this question consciously on, do you want to create drama right now to drive awareness? Or do you want to reduce drama because everyone's already aware and you just want to make it easy for them to kind of adopt these assessments, right? So in that sense, things like false positive rates and how long it takes to run becomes really important. Ideally, like a really, really low drama solution is something like a static analysis tool, which runs on every PR, gives you PR comments, and has very few false positives. That's a low drama event. A high drama event is like a pen test, which is manual, which takes 2 weeks to do, but gives you phenomenal exploitable results, which can, really, really make it lucid for developers on what's going on, right? And again, none of these are right, none of these are wrong. These are just 3 questions you should consider when you're choosing an assessment type. Okay, so how did this work for Razorpay, right? So when we started, like I mentioned, right, the first thing we did was we improved the quality of our manual penetration testing and kind of, got a bug bounty program going. And the reason we kind of did this was because we really wanted to show actually how security can cause impact in teams, right? So the best way to do that was we would do a manual pen test, we would kind of get a proof of concept, we would go present that to one team, and given the transparent nature in which Razorpay works, we were okay kind of demonstrating that to other teams as well, to say, hey, look, this is what happened to that team, this could happen to you as well, this is how they fixed it, and this is probably how you should do it. This was obviously not scalable, right? We could do this, it was limited by resources. So once kind of this manual penetration testing thing worked and people were a little more aware, we doubled down on SAST, right? We kind of made sure that, we used a tool called SandGrep, which worked very well for us. But basically what we did was we made it very easy for developers to adopt. We made it very transparent on how they have to fix it. And we made it very, very, we created incentives for fixing things early in the life cycle, right? It meant faster time to release. It meant lesser number of follow-ups from the security team and so on and so forth. And finally, we created a feedback loop between different assessment types, right? If even after having static analysis, if let's say a bug bounty hunter found a vulnerability that we had missed, then we would write a SandGrep rule for it, so that going forward, other teams can find it even before it happens, right? So this kind of a framework on choosing what kind of assessment type we want, and then kind of creating a feedback loop really helped us scale our assessments. Okay, so let's move on to the next one. So now you've figured out your assessment types and you've figured out how to find vulnerabilities. Let's say you also have a reasonable rhythm with your development teams on how to fix vulnerabilities. Next comes, how is the org doing on a whole, right? Are you improving over time? The 2 questions that executives usually ask about security programs, and this is true for application security as well, is 1, is our program getting better over time? And 2, are the investments we make giving us reasonable returns, right? The tools we buy, the people we've hired, the processes we have in place, is that working, right? So to answer these questions, I propose 4 metrics that we should track on a regular basis, right? So first one is what's called code coverage, right? Which means how much of our code is covered by our assessments, right? And you can't build code coverage without building an inventory first, right? Because you don't know how many applications you have. So build an inventory and figure out how much of your code is covered by assessments. So if you have if you're doing SAST, and let's say you run SAST on 50% of your application, then that's 50% coverage, right? If you're doing manual pen testing only on high risk applications, then code coverage for high risk applications for pen testing is 100%, but it's probably like 10%, given only 10% of your applications are high risk, right? But it's important to have code coverage at multiple levels, right? Per assessment type, per business unit, and for the entire company. Next, once you have code coverage, the next important metric to track is defect density, which means of the code that was covered, how many defect exists for 1,000 lines of code. And that's an example. You can make it 10,000 lines of code, 100 lines of code. You can also say, instead of lines of code, I'll do per application. So you can say of the applications covered, how many defects exist per application. That's also a reasonable definition of defect density, right? So you have code coverage, which tells you how many applications, how much of the software is covered by assessments. Then it tells you, what is the average number of defects you have per unit, right? Which can be lines of code or applications. And then the third metric is how quickly did you detect this, right? When you detected the bug, was this written 3 years ago? Was this through a check-in last week? And so on and so forth. That tells you how early you're kind of finding vulnerabilities. And finally, MTTR, which is probably the most common metric used anyway, which is how much time did we take to fix these vulnerabilities, right? And I think if you track these 4 vulnerabilities religiously, you can get a very good sense of where you stand today. And when you track this every day, every week, every month, you also get a sense of how your program is growing or how your program is getting better, right? The one caveat, so there are a few caveats I want to add here, right? So the one thing these metrics do not do is they do not tell you how good the quality of your assessments are, right? So for example, if you turn off all your static analysis rules, right, then your code coverage is going to be 100% and your defect density is going to be 0, and you're going to be very happy, right? But that's obviously gaming the system, right? So keep in mind, there's a limitation of this framework, is that it doesn't measure the quality of the assessments. You'll need different metrics for that. But assuming good quality of assessments, this tells you how development teams are doing. So that's the first caveat. The second caveat I want to say is that there's not a whole lot of value aggregating these metrics at the company level. So when you say code coverage 60% for your entire company, and let's say your company has 1,000 developers, doesn't really make too much sense, right? But when you break it down by business units, or when you break it down by engineering manager level, so let's say there's an engineering manager who manages 4 different applications, and for him or her, if you say for them, if you say here's your code coverage, here's your defect density, that actually means something. That's actually a meaningful metric which they can use to improve the security program, right? So it's important to slice and dice this data in various ways that makes sense for your company, right? And finally, I think it's good to have a target metric for each thing. So for instance, if your software composition analysis code coverage is 70%, then you should say, hey, by Q3, we'll get to 90%, right? Now, you may or may not get there, but it gives you kind of a target to aim at and therefore improve over time, right? And it's really good to kind of commit to these things publicly within your company. So you have like a incentive mechanism to actually stick to those. So in general, first, figure out what assessments you want to do, then figure out the measurement tactics for these assessments and for the bugs discovered. So once you do those 2, what's next, right? Before I get there, I kind of want to talk a little bit about how this helped Razorpay as well. One of the things we did was, once we decided on these metrics, we used an in-house BI tool, a business intelligence tool, to track some of these metrics. This made it very easy for engineers to access them, right? Typically, security teams kind of, go down the rabbit hole and create their own BI tool, which nobody has access to, which is very hard to understand, etc. Instead, we said, we'll go where the developers are and we'll give the metrics there, right? MTTR was, of the 4, MTTR was the one which we tracked like hawks, right? So we gave teams SLAs, and when they missed SLAs, there were consequences, there were escalations, etc., etc. And finally, MTTD was really hard to calculate at first, simply because, when you start a program, it's hard to know when the code was written or where the code is assembled from, right? So over time, we kind of developed other heuristics to kind of figure out how to calculate MTTD. But at first, it was kind of hard, right? And the data have to be manually captured. So if you're having a hard time figuring out how to do MTTD, don't sweat it. Focus on the other 3. Over time, you can improve how we do MTTD as well. Okay, so what's the next framework, right? The next framework, this is classic for all security leaders. This is like a constant argument you always have, which is on build versus buy, right? You figured out SAST is useful. You figured out you want to do manual pen testing. Do you build this capability in-house or do you buy it from outside, right? And I think this is an endless debate which will go on for long after this call, long after this presentation. But I want to give you a framework which helps you kind of understand, okay? And let's start with this assumption. Let's assume that we always build, okay? Except if certain criteria is met, right? If there are some exceptions which are met, okay? Let's just play along with me here. Now, once you kind of have that heuristic, right? Saying, okay, we'll build by default, except when certain conditions arise. Now you got to define what those conditions are, right? The conditions are like what's presented in this framework here, right? So first, is there a risk involving a third party, right? If there's a risk involving a third party, then you have to build. You can't really buy, right? So for instance, if you're doing due diligence on a company that you're about to acquire, and you don't want to involve a third party because you don't want this information to leak out, then yeah, then you got to kind of figure out how to do it with the resources you have, right? But let's say there's no risk involving a third party, so that's good. So then the question is there value in having an outside-in perspective, right? So things like threat intel platforms or static analysis rules, etc., are very hard to write in-house because you'll have to write rules for all of Java, or you'll have to figure out all the threats that are happening in the world. This is very resource intensive. You're better off having somebody from the outside kind of give you that information. So if there's no risk in involving a third party and there is value in having an outside-in perspective, you should probably consider buying, right? Now, if there is value, but you don't have an affordable turnkey solution, you should probably still build, right? Because what happens is sometimes you may have an amazing solution, but it may not be affordable, right? Or it may need a lot of customizations to make happen, which you have to build in-house, right? In which case, it may be a better decision to build versus buy. And finally, from a cost prohibitive perspective, I don't mean just money, but also from a skill and time perspective, right? So for instance, when we decided to buy SemGrep, we could have used the open source version of SemGrep, but we had a very small product security team at that point, and we didn't want to use the resources we have just to kind of customize the open source tool. So we chose to buy. But later, there were other things where we had the skill in-house, so we chose to build it, right? So I think these 4 questions, if you ask, it kind of scales really well, right? And you're able to make build versus buy decisions better. A couple of caveats. It's very interesting to understand the business need. Sometimes time to implement is very important, in which case, a decision, may be made, even if some of these criteria do not meet. And this framework is not to kind of glorify building, right? In some companies, you may have to buy everything, and that's okay, right? But one pet peeve I have is that a lot of security leaders sometimes buy as a risk management strategy, right? So when something goes wrong, you can blame the vendor. I think that doesn't work, right? I mean, it may make you feel good in the short term, but in the long term, you're better off owning entire risk management on your own. So that's one pet peeve of mine where I don't like buying, or I don't like advocating buying just to kind of spread your risks. Okay, so this is the build versus buy framework. So how does this help Razorpay? First advantage is that we are a very engineering heavy company, right? We really take pride in having a world-class engineering team. And it's always nice to give engineers cool projects to work on. It keeps them motivated, and having a motivated security team is really important. So our team, the security team, really enjoyed building some of these things in-house, right? But we didn't let that come in the way of sound decision making, right? So like I mentioned, when we wanted to buy a commercial SaaS tool, we did it because we didn't have the bandwidth to adopt and customize open source software at that point. And finally, when we had to look for vulnerability management tools, we decided that it's better, to cater to build something which caters to our needs. So we took an open source project like Defect Dojo, which is a phenomenal project, but customized it to suit our needs, right? But this is when we had the engineering talent to do this. So in Razorpay, we kind of, tilted a little more heavily towards building, but your mileage may vary. Okay. So let's get to the last framework. And I believe that this is the most important framework that you have to build a DevSecOps program in your organization, right? Like I mentioned, things like application security, infrastructure security, securing your CI/CD pipeline, which to me are the 3 big components of DevSecOps, cannot scale with just the security team working hard, right? You can't double or triple your security team to meet demand, right? Which means you have to collaborate with various teams in your company to kind of make this happen, right? And I advocate using them as force multipliers, right? You should leverage other teams in your org to achieve these goals. right? Security champions is a great example that's often spoken about, and we have a phenomenally successful security champions team at Razorpay. I'll talk a little bit about that in a minute, but there's a lot more to be done, right? For instance, when you talk about training, you should really leverage your L&D team, right? If your L&D team already has a really good training platform, maybe leverage that. If they have really good relationship with training vendors, maybe leverage that, right? Secondly, if I work at the fintech company and we have like a massive risk management team, and they really understand risk, right? And they may be looking more at like fraud as opposed to like security things, but a lot of the risk management frameworks on how to quantify risk, what kind of risk is most important to us, they're actually really good at that. So if you work with them, they can actually help you quantify security risks to the organization as well. They're actually better, risk teams are better at that than security teams are. So collaborating with them actually helps you as well, right? With developers, obviously things like defect tracking, helping them remediate vulnerabilities, building secure by default frameworks. These things are things that developers can do very easily. And HR teams can obviously, you can work with them very closely to figure out how to incentivize good behavior. If some team routinely fixes all the security issues on time, you should probably incentivize them some way, right? In a way that works in your company, right? And kind of working with HR is like a really good way of doing it. So yeah, so there are many different teams that you can kind of interact with. Another example I like to give is tech support, right? Very often you see that you get reports of security issues on Twitter, for example, right? And if you let just tech support handle that, it can kind of sometimes becomes a little tricky. So what you should do is you should really enable your tech support team to talk about, how do you deal with security reports, right? You just don't respond saying, hey, we have world-class security and not engage them, right? Which is a little different from how you would, respond to, let's say, an angry user who's talking about something else. So anyway, so I think there are different teams that you can work with, and make sure that you leverage their expertise, their skills to supercharge your DevSecOps program. The one caveat I would add is that do not leverage these teams if they already do things poorly, right? So if you have a program management team in your company which is not sound, which you're not happy with, then don't go implement those systems, because clearly if they don't work elsewhere, they probably won't work in security as well. If your L&D team, for example, does not have a solid training platform, then maybe you should go solo, right? So I think the point I want to make here is that you should definitely consider partnering with various teams in the company to grow your DevSecOps in your AppSec program, but you don't have to kind of be dogmatic about it, and do what's right for the team. Okay, so how did this help Razorpay, right? So first, one of the first things we did was we partnered with program managers to streamline communication. Our technical program management team was very good at cross-functional communication, right? So we worked with them to figure out how do we send updates that work, how do we send updates that people actually read and respond to, right? So that was a big win for us. Secondly, we kind of launched, operated, and scaled security champions program across 4 BUs. This is now part of the folklore of Razorpay, and this is part of the SDLC, literally, right? Where you have certain engineers designated as security champions. We also have engineering managers who are security champions, right? And that really helps us scale, DevSecOps. We also partner with customer support on educating and alerting merchants. Right, like I said, we are a payment gateway, so we work. Our customers are merchants who sell things online, right? So when they need to be educated, it's hard for a security team to understand merchant communication, right? But customer support is very good at it. So we educated customer support on security. They educated us on how to work with merchants, and together we came up with a strategy on how to communicate with them. And finally, we had an external and internal bug bounty. Where we allowed engineers within the company to also submit security bugs, and we also gave them some bounties and some goodies, right? So that kind of motivated them to participate in the security program as well. Okay, so I think I'm on time. I have only 2 more minutes, so let me quickly talk about the takeaway. First, security culture is downstream of all culture. So whatever you do in security, it has to align with your company. So make sure you do that. And think about scale from the beginning, right? You can't start something and then think about scale later. You're better off understanding where your company is going, and then scale with it. Okay, that leaves us only a couple of minutes for questions. Do we have any questions, Brian or Vandana?
Yes, we absolutely have questions, and maybe Vandana has it present.
Yes, absolutely. So, Sandesh, SAST gives a lot of false positives, and we know that there's still a confusion. So, sometimes the SAST reports also report high issues which are not at all exploitable. So how should we
Yeah.
deal with that? Because it takes bandwidth, and even when we talk about there's no ROI for them. So how shall we
Mm.
handle them? So
Yeah.
what is your perspective on that?
Yeah, great question. Let me try to take a crack at it at two different levels, right? So one, I think it depends on where you're running SAST. Okay, so if you're running SAST
Mm-hmm.
in the pipeline, then you want to focus on rules which have high confidence, even if they're not high risk, but they have to be high confidence. So you should have zero tolerance for false positives in when you're running it in the pipeline. So you have to make sure that you use a tool which allows you to customize those things. It's very important, right? So look for things like secrets, look for obvious command injections and things like that, but don't look for like super complicated things which can have a lot of false positives. That's number one. And number two, when security teams run static analysis tools, we have the ability to triage, right? So there you can be a lot more experimental and run a lot of rules because you know how to triage, and that's okay. And that really doesn't need to scale. You probably run that once a month or once a quarter, so that's okay. The third part I will say is that on kind of like ROI and exploitability stuff, SAST is the wrong tool to look for exploitable vulnerabilities. I believe that SAST should be used to detect bad coding behavior, right? Whether or not it leads to an exploitable vulnerability. So if you're using a string concatenated query, it doesn't matter if it leads to SQL injection. You got to stop this, right? Because it's bad security coding practice, right? So use static analysis to detect bad coding practices and educate developers on how to avoid it, as opposed to going down this route of what if is it exploitable? Because if that's becomes such a high bar, then in the end, pentest becomes the only game in town, right? And that's counterproductive for scale.